Level measurement is the measurement which will tell me about the level of certain parameter or certain material in a tank, for example. So I want to know this level. What is the level? Now, what material to be used? I mean, this kind of measurement to be applied to what material? We can apply it to liquid or to solid, but if solid, it's supposed to be in powder shape or in a small particle shape. Now, the level measurement, sometimes we need it to be accurate, other times we don't need the accuracy to be high. So this is going to tell us about the type of sensor to be used. Sometimes the sensor, we are using it with highly accuracy because the level is very much important to me. Sometimes it's not that important, so we are not going to go for high accuracy sensor. Let us go through them and see what do I mean by that. Dipstick is kind of measurement for the level. So dipstick is nothing but having kind of stick, and we insert it inside the tank which we want to measure its level, as you see here, as seen in this picture. So he's having the dipstick which having range in it, scale in it. So he will put it inside, he will take it up and measure the quantity or the level of liquid inside the tank. This is similar to what we do in the car when we are measuring the oil engine. Oil engine is to be measured by dipstick, but even for the oil engine measurement, we are not checking the range. We don't want to know how many liter inside. No, all what we need to know whether we reach certain point or not. If it's below that point, that means we need to take action. So also this is to be measured by dipstick. Here is another method to measure the level of liquid. That's float system, or with the float system. In the float system, we are having a float which is placed on the surface of the liquid to be measured. As the liquid level increase, the float will go higher, and by the help of this weight, the roll will rotate. This roll will rotate, causing the pointer to move, and the pointer will move to give me the indication of the water level or the liquid level at that position. This kind of measurement have a typical measurement inaccuracy of plus minus 1%. That means there is 99% of accuracy for this kind of measurement. The pressure measurement device. In the pressure measurement device, we are having two techniques. We are going to study them after this. We will see them after this. Like open-topped vessel. This is the vessel and it's open from the top. If the case is like this, we will have a pressure transducer or pressure sensor here, which will measure the pressure which caused due to the water level. How this is happening? Of course, as you are increasing the level of the liquid here, as you are increasing the level, the pressure on that point will be higher and higher. And this is going to make relation between the pressure and the level or the height. And mathematically, the equation representing this is given here, where H is equal to P over rho G. Rho is the density, G is the acceleration due to gravity, and P is the pressure. It's very clear that P is representing H, or can having clear relation with H. The higher P, for example, that the higher the H going to be. The other method is for sealed vessel. In sealed vessel, we are going to measure the pressure in both sides, in the bottom part of the vessel and the upper part of the vessel. In this case, we are going to use differential pressure sensor to measure the pressure. So this differential pressure is going to measure the difference between the pressure on the upper side and the pressure of the lower side, and it will generate the proportional signal. In this case, the height or the level means the height. The height is to be measured as delta P, means the difference between the two pressures, divided by rho into G. Incapacitive level measurement device is a device which can measure the level of liquid or even solid, but in powder shape now, or powder form. How am I going to, or what basic principle we are going to use to measure the level by capacitive type? If this is the capacitor, simply this is the capacitor, of course one of the elements which will decide on the capacitance of the capacitor is the dielectric material between the two plates. So if the dielectric material reach to this much of the two plates, between the two plates, that's going to give me certain capacitance. As the dielectric increase between the two plates, the capacitance will change. So this is basically the idea we are going to depend on to measure the level by capacitance. You will see this in the next slide. But before I go to the next slide, I can say that this kind of sensor can be used for extreme condition, like very high temperature situation, like liquid metal, or sometimes, or it can be used for liquid gas. That means for very low temperature. For corrosive liquid, like in acid, we can measure the level of acid. And also it can measure the level in high pressure situation, when the pressure in the material or in the liquid to be measured, if the pressure is high, we can use this kind of sensor. In capacitive level measurement device, we are measuring the height by measuring the capacitance. The capacitance which to be measured is the capacitance between these two plates, where these two plates are having the the radius of A for the inner plate and the area of B for the outer plate. Of course, the equation which relating the height to the capacitance is finally written as you see here. What is the actual relation we want? It's the relation between H and epsilon, where epsilon is the relative permittivity. Epsilon is affected by the material between the two plates, the liquid between the two plates, which the liquid we need to measure its height. As the liquid rise, the effect of epsilon will change, because epsilon before the liquid rise, it was the effect of air only, but as the liquid rise in between the two plates, we will find that epsilon is coming as a result of the material we are measuring its level. So that's how, which will affect the capacitance, of course, and it's going to tell us about the water level. That's how we can measure the level of a liquid or water or liquid by using this kind of sensor. What will happen if the material which we are measuring its level is conducting material? If the liquid we are measuring, like water for example, the drinking water is conducting material. So if we want to measure the level of drinking water, as once the water reach to the two plates, let's say reach to this point, is going to short circuit the two plates. They are going to be linked to each other. So the theory of capacitance will not be existing anymore, because the two plates are going to be considered as a one plate since they are short circuited. That's why to do this kind of measurement, the simple technique we can use is isolating the plates. Isolating the plates means we can encapsulate each plate by isolating material. So this encapsulation will make this plate and this plate isolated from the material to be measured. So if we do this, we are not going to have the problem of short-circuiting the two plates, which allow us to do the measurement even for conducting material. Ultrasonic level gauge. Here in this kind of level measurement, we are going to use ultrasonic transmitter and receiver. So we will have device to transmit or send a signal with high frequency. The signal will reach to the surface which we need to measure its level, and it's to be reflected. The receiver or the ultrasonic receiver will receive the signal, will analyze it, and the result of this analysis will tell us about the water level. The simple way of analysis is just to measure the distance or the time taken from the signal since it left the transmitter until it come back to the receiver. I mean the time taken for the signal to start from here until the surface and coming back. It's going to be different if the water level or the level of the liquid is at this point or at this point. So as the liquid level getting higher, of course, the time taken for the signal to transmit and reflect going to be shorter. That's how we can use the ultrasonic level gauge to measure the level of the liquid. Translational motion measurement. Here we are going to measure the translational motion, where we can consider or we can use this kind of measurement as a primary transducer measurement or secondary component in measurement. What does it mean here? In a primary transducer measurement, that means we are using the sensor by itself to measure the displacement, or we measure the translational motion. That's the motion in a straight line. And a secondary component in measurement, we can use this kind of sensor to measure other quantity rather than the translational motion, such as the pressure, the force, acceleration, or sometimes temperature. All of these things can be measured by the use of translational motion measurement. A resistive potentiometer is kind of displacement measurement, where in this kind of measurement we are measuring the displacement in a form of voltage. How this can be? If you look at the figure here, we are having a voltage Vs applied to a variable resistor between point A and point B. And the output voltage is taken between point A and point C. The output voltage is taken between A and C. Of course, that the output voltage is going to be proportional to the resistance between A and C. That means if the point C change, as it's increasing, its resistance will increase, which is going to cause different voltage. So the displacement which we want to measure going to affect the point C. It's going to move the point C in the potentiometer, which will result in different output voltage, which will be proportional to the distance between A and C, which coming as a result of the displacement. The displacement can be shown clearly here in this relation, where the relation is showing us V out over Vs, the output voltage measured, divided by Vs, is equal to AC over AB. AC over AB. Remember, the distances AC and AB for us are resistors. So they are representing the resistance of the potentiometer, either the resistance part AC or the total resistance AB. Of course, here this relation is showing us any change in AC, in the resistance between A and C, going to cause a change in the output voltage. So the displacement or the translational motion going to change the distance AC, which going to affect on the output voltage V out. For this kind of measurement, the maximum error is to be calculated as a 2RT over 2RT plus 9Rm, where RT is the resistance of the potentiometer between A and B. Rm is the resistance of the measuring instrument, the instrument which will measure the voltage, and Vm is the measured voltage by the voltmeter. Another technique used to measure the displacement or the translational motion is called linear variable differential transformer, LVDT. This is the one you attend in the lab, one experiment you have done already on LVDT. This kind of sensor, depending on the theory of a transformer. If you can remember the theory of the transformer, the idea of it is we are applying voltage at one side, which called the primary, and the secondary are two coils, coil A and coil B. They are connected such that the voltage generated by A opposite to the voltage generated by B. So if I add them between these 2 points, I mean the output voltage will be 0. When this is going to be 0, if all the magnetic field reaching both secondaries are the same, means this coil going to generate have current. Current will generate magnetic field. Magnetic field will cross this bar, which consider as the core. It will cross it, or it will go through it to the other side. So if the magnetic field come to coil A, equal to the magnetic field reach to B, that means VA will be equal to VB, which means the output will be 0 because the output will be VA plus VB. And we said the arrangement made such that one of them is opposite to the other. Now what is or how this is going to give me the result on the output? Let us take this piece, this bar, to the bottom. If I take it to the bottom, so it's going to be at this position, for example. When it's at this position here, this is the piece, you are going to find that the magnetic field crossing here, this magnetic field crossing from the primary to secondary A is going to be going to be very low, because it's going to go through the air, and the air is acting like high resistance to the magnetic field, as compared to the other one, which the magnetic field going to cross through the core, through the piece here, this piece, which I shaded by red color. So you will find more magnetic field coming to B, which means when I want to look at the output here, the output is not like before. The output between these 2 points, there will be a voltage, because the voltage VA going to be smaller than VB, which means the output will give me certain volt. Now what caused this voltage to be? What caused this difference between A and B to happen it is the displacement of the internal bar, this bar. I cover it by different color this time. So when I take this bar down, I will find the voltage in B more than A. If I take this bar up like this, if the bar come here, you are going to find that the voltage on A, or the voltage generated at A, at coil A, means VA bigger than VB, which I can conclude it by saying if any displacement happened or given to this bar, it's going to result in voltage on the output. And also the polarity of the voltage will tell me the direction of displacement. Here it shows us the position of the bar when there is a motion happen to this bar. You will find that here the magnetic field is going to cross to the other side. Magnetic field will cross to the other side through air, most of it through air, but here you will find the magnetic field has good path to go through, or good medium to go through. The voltage VA is given by the equation Ka sine omega t minus theta, and the voltage VB is given as Kb sine omega t minus theta, where the output voltage here is VA minus VB. And as I explained in the previous class, in case of no motion applied, VA will be equal to VB, but the angle will be different by 180. As I told you, this is the connection, so their total will be equal to 0. This figure is showing us how the motion going to make changes in the voltages. So the primary voltage is this one, the red color is given here. This voltage is given here. And if I look at the secondary one and secondary two, which called VA and VB earlier, look at the blue color is coming from this coil, from the blue coil, and the green color comes from the green, and their total will be this color, this one. So you will notice that at certain position the output voltage will be 0, and when the displacement goes from left to right, it's going to show us which one is having higher voltage. So when the voltage of the blue is higher, the voltage on the output here will be positive, and when the voltage of the green is higher, the output will be negative. That's going to tell output means this one. If VA equal to VB, which this position, they are going to be opposite in term of angle. I mean, they are shifted by 180 degree, so their total will be 0. Let me find you the position of positive now, position of negative, and position of 0. We will start now. This is more positive, more negative, and this is 0. That's it for this kind of sensors. I hope everything is clear. Thank you very much.